Guys, today we'll see what would be the increase in the heat in the brake disc, and also what is the energy produced. I think it is all basic physics. So if a bike with the rider is around 250 kgs and is riding at 108 km per hour, why I have taken this 108 is that 108 km per hour, if you divide it by 3.6, you divide by 3.6, you get it as 30 meters per second. So I want this round figure, so I have taken 108. Okay? And E comes to stop in 4 seconds. So time of braking is 4 seconds. Time of braking is 4 seconds. So now we are supposed to find two things here. I think we can actually extend this problem and try to calculate a lot of parameters related to, lot of things related to braking. One is we can actually find out what is the heat produced during braking. Okay, that is very easy. So heat produced in braking, what is heat? Heat is basically energy. There is energy conversion happening, kinetic energy. The bike is moving at 108 km per hour. It comes to stop, and that energy has to be converted to heat energy at the brake system. So let us see that what is the initial energy. So kinetic energy is converted into friction. So friction, that is heat. So let us find out what is the kinetic energy when it is going at 108 km per hour. So kinetic energy is given by the formula half is equal to K is equal to half m square. So it is half. Mass of the vehicle is around 250 kgs along with the rider. And here V is actually V, it should be actually delta V. Basically here we have to write this as, we can write this equation as half into m into v square minus u square. Basically here if all the energy is lost, all the velocity is lost, and the final velocity is 0, and therefore this u will become 0. So here velocity is here how much? 30 meters per second. 30 meters per second square whole square minus 0 meter per second whole square. Sorry, this actually sits for this whole thing. Okay. So here, so half into 250 kg into 30 square, which is actually 900 meter square per second square. This, so can you tell me the answer, Sethi? So can you give me the answer? A calculator thing. Double one, 25. Huh? Guys, kinetic energy. So here you got kg. So this can be written as kg meter square second square can be written as kg meter per second square into meter, or you can write it as 250. So that is Newton meter or joule. Since 1 Newton meter is equal to 1 joule. Now, if this guy rides the bike at this speed and actually makes an abrupt braking, okay, and stops the vehicle in 4 seconds, finally all this kinetic energy is absorbed. Now what do you think would be the rise in temperature in the brake system? Brake system ಎಷ್ಟು temperature rise ಆಗಬಹುದು? Because kinetic energy is lost here, so many joules of heat energy has been produced. Okay, how much would be the rise in the temperature in the brake disc? Will it become too hot like 500 degrees centigrade? Will the rise in temperature be around 5 degrees centigrade? I think you feel by sense that 5 degrees is too small and 500 is too large. I think it should be some degrees of rise in temperature. And which end of parts in the brake system will actually get heated up? Brake pads and discs. And some part of the caliper assembly. Okay. Now out of that, let us assume that since the brake disc is rotating, since the wheels are rotating, since it is exposed to circulating air around it, around 60% of the heat is actually taken away by radiation and the convection. Okay, let us only consider around 40% of the heat to be completely taken away by only brake disc. Brake disc estimate irbodu. You know what is brake disc? You know brake pads and brake disc. Now what can be the weight of the brake disc? Bike-alli brake disc ಎಷ್ಟಿರ್ಬೋದು weight? 700 to 800 grams. So let us make it as 1 kg, around of 1 kg. So let us assume that we want to know what is the rise in temperature in the brake disc. Let us assume with your sense that let brake disc be of 1 kg size, 1 kg mass. 1 kg mass. So here this kinetic energy is getting converted into heat energy and only around 40% is retained in the brake disc. So let us say that suppose if energy is given to something like some mass, if you want to know what is the rise in temperature, we use the formula that heat energy is actually equal to mc into delta T, where m is the mass and c is the specific heat of that material and delta T is the rise in temperature. And if you actually try to find out in the internet what is the specific heat of the brake disc, you get the C as 460 joules per kg per Kelvin. What does this mean? That means it needs 460 joules of energy to rise 1 kg mass of brake. It's 1 kg mass by 1 degree Kelvin or 1 degree. Because 1 degree rise in Kelvin equal to 1 degree rise in Celsius. Okay. Incremental degree Celsius and incremental Kelvin is same. Okay, both are, though you have some conversion, both increments are same. So you can either write it as per degree centigrade or per degree Kelvin or whatever. Okay. So you know the C, you know what is M. Now what is the weight of the brake disc? 1 kg. So if around 40% of this heat is actually kinetic energy is going as heat, then what would be the rise in this delta? So you can definitely find out delta. Okay. So let us now heat energy. Let us put this as 40% of the kinetic energy. Let us put this as 40% of the kinetic energy. 40% of the kinetic energy is how much? 45,000. Which is actually how much? 45,000 joules. 45,000 joules, which is equal to how much? 40. So M is to 1 kg. C is to 460. 460. It is joules per Kelvin, joules per kg per Kelvin, or degree centigrade, multiplied by delta T. Guys, I'll write here because the video will not be able to capture anything below this line. And let us go here. Now, what is this delta T1 now? 97.82 degrees centigrade. Guys, so that means that this can actually become like it can increase the temperature by 97 almost 2 degrees centigrade. Is it acceptable? Is this acceptable temperature? Yes, definitely. If you would have actually by chance, if you would have actually braked so hard and immediately if you went and actually had the courage to go and touch this, so then you would definitely burn your fingers because that would be so hard. Okay. So this is the problem related to the increase in temperature of the brake disc due to change in velocity. And also multiple problem.